So when Dinesh and Wayne asked if I'd sort of organize something here, they said the idea would be to talk about experiences while a graduate student and what it was like to be John's student. Some people will expand on that a little bit with Reminiscences with John from beyond graduate school. I was going to just start with a few slides very quickly, and then we'll get to the people on that list. So first, here's a list of John's 43 students as listed by the Genealogy Project. And the Genealogy Project says he has about 900 descendants, so the count's a little bit squishy in some ways. But anyway, those are his students. Here's a picture from his 60th birthday conference, so 40 years ago. Every single person who's going to get up and speak now is in that picture, and they all look exactly the same, especially me. Barry mentioned a couple of times from Arizona Winter School. I'm not sure if this was the one Barry was excluded from, but this is 2007, John with students, grand students, and at least 2 great-grand students, possibly more. I know of at least 2 of them. And then, just to see how exponential growth works, as we teach in our calculus classes, this is Tate's PhD descendants at this year's Arizona Winter School. A great picture, which I think is the one that you had a copy of, Barry, yeah? Yeah. Okay, so I thought it would be fun to actually see his descendants. So I did some copying and pasting from the Genealogy Project. Here are his PhD students and their students and so on from the 50s and 60s, and the 70s, and the 80s, and the 90s. You'll notice the size of the font is getting a little smaller. 2000s, 2010s, and believe it or not, LaTeX 5-point font will fit the entire thing up to the 2020s. So they're Tate's students and descendants as of March. I'm going to turn it over to the first person on our list here, which is Joe Buhler, who will give us his reminiscences. And Joe has his own microphone. I hope I do.
Got it. John was a really striking thesis advisor, and he had this absolutely exquisite way of, if you came up with a question, of responding either, gee, let's talk about that, or maybe you should read this, or come back next week. But in a very gentle way that was very effective. Now, I'd go on, except that I'm giving a talk tomorrow, and it will be, to some extent at least, about my thesis experience. So I have to stop and do something different, and that is to focus on something that John liked to do a lot, and that is hike. And so I'm going to, as fast as I can, to fit the available time, talk about at least 2, maybe 3 different hikes that I took. And now let me get what was supposed to be the first slide. Okay, and now, so it's, where do I make it up full screen? Sorry, I didn't, it's a Windows machine. Where is it, where was it? Okay, great. So in 1974, John and Karen were going from either Vancouver to California or vice versa because of the ICM in Vancouver. And they stopped by Portland on their way, and I offered to take them on a hike. So I took them out to the vicinity of Mount St. Helens, where we went into a lava tube called Apes Cave that had existed for about 2,000 years, and I assured them that there had been no large eruption at St. Helens in at least 100 years, and Wikipedia will tell you strange things, like when it erupted in the 19th century, the sky was interpreted by Nat Turner as the winds blew east, as the sign for the slave rebellion. So that's a little factoid. When you go down into this, you turn to the right, and it's like you're in a very large subway tube. It's Some of it is this high, a very nice hike. When you turn to the left, come back and go the other way, it becomes clambering over rocks that have fallen from the ceiling, and it gets kind of dicey. The temperature is basically 43 degrees no matter what time of year, but you have flashlights, it's pretty tricky. I was actually concerned because I remembered doing it 10 years earlier, and there were fewer rocks on the floor of the lava tube. Anyway, we had a great time. 6 years later, now if I, let's see what, okay, how do I, there, I did it. Was that, you're doing it. Thank you. I knew I didn't have to think about that for some reason. The only photographs of Mount St. Helens eruptions on May 18th, 1980 were by, let me get this right, a photographer who had set up overnight camping named Gary Rosenquist. And he got about 21 shots in. The camera was going automatically. Here are 4 of them. After 10 seconds, you see a little poof, and so on up to 60 seconds. That cloud was coming towards him, as he wouldn't know, but at about 330 miles an hour. And so he had to get his 3 friends and all their camera gear in a car to go 100 miles an hour the other way. And the cloud did overtake them, but they'd gone fast enough that he escaped. There's no other signs of the eruption. Scientifically, this is very interesting because what it started was that collapse. You can see the collapse from there to there. That was the first sign. And by the way, St. Helens is still probably the most active volcano in the continental United States, and it is building another dome. Just thought you'd like to know. People have had a lot of difficulty dealing with these slides because, first of all, the camera's jumping up and down. Secondly, there were varying spaced gaps. But 2 years ago, Steve Rosenau took all those slides and used AI. This is an AI-generated image. And it really is only really the big part of the eruption is now over there. But this is the cloud moving at some number of hundreds of miles an hour toward them. In any event, that was certainly quite interesting. The 3 of us enjoyed the hike, and we didn't even have any insight about this. Okay, the next hike was during the Corvallis conference, when Bill Castleman and I decided, hey, we would take John Tate and Robert Langlands out for a little hike. And we heard about Three-Fingered Jack, and Bill and I had both done lots of climbing in the Northwest, and we asked around about Three-Fingered Jack, and we got not very specific opinions about it. Namely, roughly, there's a long hike up to near the top, and then there was a little scrambling, 5.4, but it's not very hard, except there's huge exposure. We finally decided to do it, and now I'm going to, okay, now you're really going to have to help me get to the video because this is full screen. What do I make that go away? That escape, okay. Yep, no, it's right over here. Yeah, okay, boom. Did that work? Boom, there we go. Okay, a guy named Matt Cook. Okay, I gotta get this started in the right place. Hiked Three-Fingered Jack and tried to take photographs with his GoPro. And you can see exposure on either side. The GoPro in some places magnifies the feeling, but there it didn't.
In this video, we will be going to the summit of Three-Fingered Jack. This is a smaller Cascade Peak in the Mount Jefferson Wilderness. Though it is smaller at about 7,800 feet, it is one of the tougher Oregon mountains to summit. The trail goes up the PCT from Santiam Pass, then leaves the PCT to follow a ridge up the summit.
Okay, that gives you
Our
a
journey
feeling
began early in the
of what it looks like. And here's the trail up.
an easy hike, but eventually becomes much tougher. With the mountain in sight, it was time to get ready for some tough climbing. Leading the crew was Danny, who I've climbed with before, along with Megan and Jesse, who are part of Search and Rescue.
Now, so you now know how to get this on YouTube. He is
To reach
trying to
the highest-
persuade you that it's crazy to go up there without ropes. And this part of it, I think, conveys some of that.
After all that, I had made it to the summit of Three-Fingered Jack. The summit of Three-Fingered Jack.
Okay, I'll try to stop with this one.
I was very thankful to be
Okay, so now I don't have to worry about that. Bill and I agreed we were responsible for our respective advisor, and it got pretty dicey. Or in Bill's case, mentor. It got pretty dicey, and for instance, there was crossing a scree slope, which John sensibly, more sensibly than the rest of us, decided he was a little leery of, and but we did it. There was a chimney. Both John and Langland's got careful advice on where to put their feet to get up the chimney, and then you come up to the first real peak, which is over there. About the four of us fit on that, and that's about all. Bill remembers John sort of flopping accidentally with his head over, looking down, and then sitting up like that. And Langland's just sitting there holding on to the register. I don't see a register anymore, just holding on to it till we went back down. And of course, that's not the actual summit. There's approximately a 6-inch wide path to a slightly higher knoll that fits at most one person. And both Bill and I took turns doing that. And now this is looking back at that, and that opening shot with his GoPro works really well because it's kind of 6 inches. You can actually in some places step down, and boom, it goes all the way. You know, you'd fall 1,000 feet and then keep rolling. In any event, that was a very memorable hike for all of us. Very quickly, do I have time for one more thing? Sure. Okay. No? Okay. There's one other hike, I'll just say it very quickly. When John was 90, I went to Hawaii with him. He insisted on swimming in the ocean every day. I was stunned that a 90-year-old had to go down every day and hike. Swim, and then he would go up and he'd want to do hiking. It was just amazing. Anyway, those are my memories of 3 hikes with John.
Thank you very much. So next up, I'm going to all right, maybe you could find the PDF. But next up is Greg Call, who is a classmate of mine.
Thanks, Joe. So I don't have any volcanic eruptions to tell you about. Instead, I'm going to tell you a story that takes place over many years as John's student, and his reactions to what can only be described as my extreme naivete. I must say this is a fabulous picture of John, and it's very much an expression that I remember and perhaps induced on more than one occasion. My story starts with John as a graduate student advisor calling my home, much like Henri related to us earlier, and speaking to my mom. I went to college in my hometown. I had started taking classes there in high school because they were free, and it enabled me to graduate early. And so when John called to tell me that I was going to be admitted to Harvard, and my mom answered, I was up the street at Dartmouth, taking a math class. And so she had arranged with him that he would call back in the evening. And so I, in the intervening afternoon, learned who John Tate was because, frankly, I had no idea when he called, and my mom told me this nice man had made this phone appointment. So I went and told my professors at Dartmouth that I had gotten this call from John Tate. And of course, they told me who he was. And I was convinced at that point, of course, that I would go to Harvard and that John would be my advisor. And so we had a lovely conversation that evening, and I went to Harvard with that plan. And in my first year, I think perhaps my saving grace and John's was that he was away on sabbatical. So I didn't have a chance to implement this plan until my second year, when I very quietly knocked on his door. I did this several times and finally found him. Went in and introduced myself and recalled that he had called me, of course, and we'd had this lovely conversation. And asked him, after about 5 minutes of just general conversation, would you be my advisor? And I got a rather startled expression. But he was gracious enough not to instantly, tell me how ridiculous this question was. Instead, he sort of didn't really respond, but said, maybe you should take some classes and we'll talk later. So I did, and over the course of another year or so, I began actually to initiate conversations with him. And I learned, or figured out later, that really the several papers he gave me to read were really more of an audition. And thankfully that went well. And so we got to the point where he'd given me a rather substantial paper of Sayre to read. And I remember we had several conversations about it and had begun to talk about questions that might follow, that might be extensions of the paper. And so we were getting into that, and it began to feel like maybe I would have a thesis topic out of this collection of questions. But as our questions refined, John sort of got a puzzled look on his face and then a raised eyebrow, and he went over to his file cabinet and found a paper that John Milne had recently sent him. Jim Milne recently sent him, and then we looked at the paper, and of course 98% of what we had thought were open questions Jim had solved. So that was the end of that topic. But of course I was exceptionally lucky that I hadn't worked on that for an extended period of time. It came to pass that I was blessed with multiple thesis questions. John suggested something about variation of heights. Barry suggested a question. There was another question that came out of a paper of John and Barry. And I began to work on these and made modest progress. In my fifth year, John said to me, well, I think you have what you need for a thesis. And I was actually quite surprised because I didn't feel that I had answered these questions really up to the standard that he set. I mean, we were always talking about, elegant solutions and statements that really were clear and seemed like that they captured the essence of the problem. And I didn't think I was there yet. I thought really the things that I had were more like ugly lemmas on the way to some better results. And so I then gave a puzzled look back and said, I didn't really want to graduate, because I wanted to work more on these questions, which I think surprised him. And so he explained to me, well, you probably won't have that much support, in this if you decide to stay in terms of finances. And, so I thought, well, okay, I can teach. And truthfully, I'd begun investing in the stock market, and I'd done okay. So that was a backup plan. And the other thing to know about me is that I'm exceptionally frugal. So, I stayed that last year and ended up writing what was, I think, the second longest thesis in my time at Harvard, which was from 80 to 86. And I remember presenting to John the first 3 chapters of this thesis, which numbered at that point about 151 pages. And so I handed it to him, and this is pre-tech, So these were typewritten pages, so God bless, one of our secretaries that had typed this up for me. And so I presented it to him, and I was excitedly telling him about the 4th chapter that was going to come, and he sort of took it and weighed it, so did this and sort of said, "Don't you think this ought to be enough?" Well, I was a little bit heartbroken, but I persevered and presented a 4th and a short 5th chapter. And I know Joe got stuck reading the 4th chapter. But he later told me, because I ended up taking my first job at Tufts and stayed in the area, and he told me after I graduated that, well, actually, he liked the 4th chapter best. So it was a modest, happy ending. I think, John was always very kind and patient with me, despite my extraordinary naivete. So.
Thank you, Greg. Next, Joe Carroll has a few remarks. Thank you, Joe.
Got some notes here. So I came to Harvard in '69 and finished in '73. In my second year, I took a course from John entitled Symbols and Arithmetic. And as a result of that, I ended up working in K2. I think actually Dustin Clausen mentioned that he had proved a particular isomorphism, and I think he actually did that during one of the classes, as it turned out. One thing, of course, that's been echoed here a number of times is his generosity, and it wasn't uncommon for me to knock on his door, and if he were there and willing to open it, he would often give me a personal lecture, maybe a couple of hours long sometime. And the year I finished, 4 other people finished at the same time. So he was doing this across the board. I'm not sure I ever had a good idea about K2 with regard to my thesis, but I had one good idea at one point along the way about something else to do with K2. And as a result, I got a trip to Seattle, Washington for a conference on algebraic K-theory. And so John and I were flying from Boston to Seattle together. I don't remember a whole lot about that flight except for maybe 2 things. One was that there was some turbulence, and I desperately didn't want to vomit in either of our laps. And the second one has to do with his modesty, and that was that he was talking about some people he really admired mathematically, people who could both do deep mathematics and also quick mathematics, understand mathematics quickly. And so he was somewhat in awe, in a way, of David Mumford. And I guess David Mumford, he should be in awe of to some degree, but this was also John Tate. The final point, I had a postdoc, and I didn't do anything very stupendous during that postdoc. And then I got a job at Wisconsin, where I had the august title of visiting assistant professor 1975 through 1977. And I decided to stop doing mathematics as a career, and I had to contact John for one more letter of recommendation. This time it was to medical school. And I had applied to a program in the University of Miami which was accelerated. So that what they did was they converted PhDs in science to MDs in 2 years. And I never actually saw the letter of recommendation, but I did find out sometime later that somewhere in it he had said something equivalent to anybody who could get a PhD in mathematics ought to be able to do this easily.
Yes, thank you. Okay, so Dick Rose sent a video because he unfortunately wasn't able to make it, which we'll play at the end. So next up is Jonathan Lubin, one of my professors. fact, I learned algebraic number theory from you.
Yeah, I'm Jonathan Lubin, and I was at Harvard from 1957. I was a graduate student from 1957 to 1963. My first year, John was on leave, so I never even met him until the second year. And I think it was my third year that he gave what I believe was the first of his seminars in arithmetic on elliptic curves. It was really quite wonderful. He, every lecture, it seems to me, in my weak and failing memory, that every lecture he gave several references of papers that we could look into in greater detail. It was sort of like a lawn sprinkler, just spreading out these other references. Jim Milne said that it was a golden age of mathematics, and it very well may have been. But when you live through a golden age, you're not aware of it. I said at my retirement dinner that we found out about elliptic curves from John, and they were these little, wonderful little things that were so friendly, really, and computable. Nobody would have thought that this was the beginning of the solution of Fermat's last theorem. And John was among the people who were there, and I could see that he apparently hadn't thought of that in quite that way. Weiho said that he was approachable. Oh, that's only part of it. He was really infinitely approachable. You could, somehow or other, he was by far the friendliest member of the department in those days. He was certainly the only one that I would think of inviting to a party that I gave for the other graduate students. And he came. He was, as everybody has said, he was very generous. You go into him with a little gem that you thought you found, and he would take that little gem and set it in a much more beautiful and broad setting to show you what you really had found. After 5 years, I was getting absolutely nowhere in research. And I decided to go and take a job at Bowdoin College, 130 miles away. I had nothing like a thesis. As it happened, that summer I proved Theorem 1. And the thesis actually came together fairly rapidly, because I exchanged a whole lot of letters with John. He was a conscientious, indefatigable correspondent. I think we probably exchanged 5 pairs of letters at least in that first semester before I started writing up my thesis. And speaking of, when Greg said that John took his thesis, with me it was not quite the same thing. I took my thesis into the bindery between Harvard and MIT, where I guess they bind all of the theses. And the woman on the other side of the counter took it like this and said, "You guys get away with murder." One anecdote that a lot of you have read, I'm sure, and that is that long before I started working on formal groups, I must have been something like a second-year graduate student or something like that, and I went into John and asked him if he knew a good problem in class field theory. And he said, "There's nothing I'd like better than to know a good problem in the class field theory."
Thank you. Okay, and next we have Kumar Murty, who was also a classmate.
Thanks, Joe. When Joe asked us to make comments, he gave us some instructions. We had to do three things. One is we had to say something about what it was like to be a student of John. Second, we had to say something that was going to be useful and inspiring to students and young faculty. And third is we had to do all of that within 3 to 6 minutes. So I will try my best to comply, but I've already used up 30 seconds. So when I first came to Harvard, I already knew that I wanted to do number theory and I wanted to work with John Tate without really knowing what number theory was and having no idea what John Tate did. Other than that, he was very famous and he was like a modern day Gauss. And so he's the one I wanted to try to learn from. Of course, got to Harvard and lots of things happening around, most of which we can't make head or tails of. The common joke in the number theory seminar, which we were doing, Jacques Langlands, and I don't know if Barry and John were sitting on the front row. The graduate students were at the back, and the common joke was, "What the heck is going on?" But anyway, I got interested in the Sartor-Tate conjecture. Somehow I figured out what it was saying. I could understand the statement. I played with it a little bit and got some results, including some cases in the function field setting. I believe I showed them to Barry, and he said, you better write to Deline because he's been doing a lot on Sartor-Tate. So I did. This was before email. You had to actually write a physical letter. I got a postcard back from Deline with just 2 lines. I have very general results on Sartor-Tate, and they're going to appear in Wave Conjecture Part 2. So that was really disappointing. And that's when I went to talk to Tate and told him what had happened. And he told me some good advice. He said, look, this is the way math is done. You prove a theorem first, and then you discover it was proved 100 years ago. Then you keep trying, and you prove another theorem, and you discover it was proved last week. And then you may overshoot. You prove a theorem, and you realize it won't be proved for a few years yet to come because you made a mistake. But then finally you zero in, and you get it right, and you get a theorem. So that's just par for the course. Don't worry about it. Just keep trying. So then I got some courage and asked Tate, how did you make this conjecture, the Sartor-Tate conjecture? And in his usual modest way, he said, look, I just did some dumb calculations on powers of elliptic curves. But if you really want to know how to do it, you should talk to Mumford because he has the right way to think about this. But I kept pressing, and where did this come from? And then he took out a typescript of his Woods Hole talk and said, look, this is coming from something more general. And that was my introduction to the Tate conjecture, and that eventually was what I worked on for my thesis. So, so that's the part of what it was like to be a student. Now for the younger people in the audience, I'll tell you three principles that I wish I knew when I was a graduate student. Often we find, and this is a common experience, I think, for many graduate students, that we figure out what it means to be a good graduate student after we're done. I wish we knew this when we were students. So the three things are, firstly, don't be overwhelmed. I mean, you must be seeing this week, quite a dazzling array of ideas, the breadth and the depth, and it's easy to feel overwhelmed, but don't be. Because remember, what you're seeing wasn't done in a day. This is decades worth of work. It's a lifetime of work. And so be focused on one thing, understanding one thing really well, and go from there to other things. And I find that it's a common experience of being, feeling that, oh, there's so much going on and I don't understand it, I understand it just a little bit. That's again, par for the course, and we just have to get comfortable with that. The second thing is that you don't stop learning. Just because you finished graduate school doesn't mean that you've learned everything that you've had to learn. You keep learning, and I know Tate himself had this attitude. In fact, I believe he or someone told me that Sayre told him that he should learn analytic number theory. Because Sayre at that time was playing with Chebatarov. He had that long paper that appeared in the IHES. And so Tate said, okay, I have to learn analytic number theory. What should I do? I will work on Stark's conjectures. But then, of course, he took Stark's conjectures and squeezed it so hard, the analytic number theory left, and it became an algebraic problem. But okay, so that's good. It's okay. So you keep learning, and you transform the problem into something that you like to do. And then the third thing is more serious. You ask, when you have experience like this, working with a great person and working with a very generous person, you ask, how can I pay it back? How can I express my gratitude? And the answer is you can't. You have to pay it forward. So many of you who are students now will eventually be faculty members. You'll have your own students. And so it's good to remember the experience we had when we were students, the generosity of our teachers and their kindness and their encouragement and their support when we were down, how they kept helping us to keep going forward, and you communicate that to your students, and that's the only way you're going to be able to express gratitude to your teachers, paying it forward. Okay, so I think I was within my time limit. Thanks.
Thank you. Ken Ribet is next, and he's sitting in the front row as instructed. Thank you.
Yeah, I'm easy enough to find. I decided to sit in the front row. Well, I have a lot of things to say about John, and I don't know where to begin, but maybe the simplest thing is to kind of say how I first met him. So I was an undergraduate at Brown, and I knew I was pretty good at math, and I knew I wanted to be a math professor, but had no real idea about how you do that. And I had two wonderful mentors at Brown, Mike Rosen and Ken Ireland. And Ireland especially kind of told me exactly what to do. You apply to graduate school, and I did, and I got in, and I got into Harvard. And he said, now what you do is you go to Harvard and you work with Tate. So I'd never heard of this, but I kind of went to Harvard, and I went to the office of the math department, which was in 2 Divinity Avenue. This building, by the way, opened in the fall of 1972 when I was a third-year student. I finished in 1973, a fourth-year student. I finished in 1973. And I went to the chair's office, and there was a secretary, and she said, well, he's very busy right now, but he'll be in soon. And he came in, and he walked in and walked out. And then I kind of followed him to his door, and I knocked on the door, which was this massive wooden door in 2 Divinity Avenue. And he opened it up, and I said, hi, I'm Ken Ribet, your new graduate student. And he was nonplussed. But he swallowed hard, and he said, well, okay. And he did what I'm just going to write on the board, some syllogism. But I want to make a connection between John Tate as a math advisor and Steve Kerr as a coach in NBA. So Kerr was the coach of the Olympic team that won the gold medal this past summer. And one of the players, I think it was Kevin Durant, said he's such a good coach because he can get in the mind of his players and see what they need. And I think that was really true of John. Like he saw who he was dealing with, and he let me alone for a while. And then at some point, I had lots of contact with him. I graded his Math 250 course when I was a first-year student, because I'd already taken the course at Brown. And I went to all the lectures. Joe mentioned K2 and symbols. Well, I went to that course, which, by the way, met Saturday mornings. It was a Thursday, Tuesday, Thursday, Saturday classes at that time. And there were lectures by John Coates and Swinnerton Dyer, and Barry Mazur gave a wonderful course on algebraic groups. And at one point, Tate came up to me and he said, "Hi, Ken, what are you doing?" And I told him all these courses that I was doing. And he said, "Okay, well, maybe now it's time for you to work on your own things." And, I said, "Well, what things?" And I asked him to give me a problem, which is kind of not every graduate student can do. I mean, it's like, well, you find a problem together and you have some discussions. And he gave me a very specific problem to work on, which, believe it or not, I rejected. It was like a lump of gold. I can tell you later sometime what happened to that lump of gold, but I didn't understand how it would work and what to do, and I came back and I said, "Give me another problem." And he did not throw me out. That's the amazing thing. But he gave me a problem that, if you look at Serre's book on abelian analytic representations and elliptic curves, there's a paragraph somewhere, the subtitle is "A Mild Generalization." And Serre had just written this paper on algebraic Galois properties of torsion points on elliptic curves, this famous paper from 1972. And we had a typescript of it. Everything was done on paper, and you send things in the mail, and we had an advanced copy, and I'd read it very, very carefully. And Tate said, "Well, now try to generalize this to the setting of what is now called abelian varieties of GL2 type." And I worked on that on my thesis. But I knew immediately that Serre could do the thing in like 3 hours. And I was kind of very, very worried that the thing would come to nothing, and my contribution to the world would be some tiny, tiny increment. And what's amazing is that if you look at the Serre-Tate correspondence, there's an index by name. And I got these volumes years ago, and I looked to the back, and I saw my name was referenced 45 times. And I decided not to look up the references. But I did that a few days ago, just to see what they were talking about. And Tate wrote, and said, "Well, I have this graduate student, Ribet, and he seems pretty good. And I gave him this problem, and I'm very worried because you could do it in about an hour and a half." But Tate sent me to Antwerp, and I met Serre for the first time, and I was completely petrified. And I told him what I was doing, and in about 45 minutes, Serre told me what to do and how to finish the thesis, which was really amazing. So I went back, and I basically did. And I was quite relieved when I looked up the reference. Serre wrote back to Tate, and he said, "Ribet, il est très sympathique," which I kind of had no idea. Okay, so I worked on this thing, and it was at the time when you were about to write your thesis, you rented a typewriter with symbol balls on Mass Ave, you brought it back to your room, and you got something called Crane's thesis paper, which is acid-free, and you would type onto that, and it would be like the gold copy of your thesis that would be deposited in Widener Library. So I was doing this, and I gave Tate, the first half of the thesis. And I came in the next day. We had these meetings that I would call tete-a-tete, and we'd go in, and he looked at it and he said, "Hey, this is pretty good, but here I think you could generalize it quite a bit." So I sort of tore up some Crane's thesis paper and typed some more, and I finally got my thesis, and it was just a wonderful experience. So I'll stop there.
Thank you, Ken. My recollection is that if you made more than one typo on a page of Crane's thesis paper, you had to throw it away. Yeah, and it was expensive stuff. Okay, so next is Shankar Sen, and I apologize for misspelling his name on this. I couldn't fix it today.
We are running short of time? Or? No? Okay. Well, most of you know many of you have heard of Ravi Shankar, and my name My first name is the same as his last name. So it's an A rather than an E. But anyway, by the way, that name of his was actually not his original, but that's nothing to do with Tate, so I better stop. So Tate was my advisor from 60 to 67. Two of those years were my junior and senior years, but I can't really separate that into undergraduate and graduate. It didn't feel that way. Okay, by now all of you know that Tate knew how to encourage students. So let me give a little bit of negative evidence, so actually it's double negative, so positive. I can remember only two critical remarks directly said to me by Tate, and one was, "Who do you think you are?" And the other one was, "People will say that I've spoiled you." And as negative comments, I'd say they're not worse than -3 on a scale from 0 to -10. But he was one of the least, hardest to irritate persons. And so coming from him, they probably had a little more bite than that. My memory is selective, so I actually remember more positive things and stronger than +3 that he said to me. But I better not repeat those. And instead, I'll mention two things that he actually did. So in graduate school, I used to live fairly close to here in Child Hall, and the TV room was on the ground floor of another building. So one day I was watching TV and Tate walked in, and it was clear that he had come to see me. Apparently I hadn't shown up for a long enough time. So we didn't have a regular appointment at that stage, but probably, if you don't see him for a few weeks, several weeks, he notices it, and he'd come by. So it was fairly clear that it wasn't a coincidence. It was roughly on his way home from Divinity Street to Divinity Avenue, or what is it, to where he lived, but he couldn't have tracked me to the TV room just by walking home. And anyway, so that was incident number one. And the second thing was in senior year, I got a call at the dorm. So there's somebody else talked about being called at home. In this case, I was able to answer the phone. And so he said that, this was about time to apply to graduate school, and he suggested that I apply to Harvard, and he said that some Midwestern universities are offering large scholarships, and he was concerned that maybe I would think that one of those would be a good idea. So I hope nobody's offended, but essentially he recruited me to come to Harvard. And of course, it's by no means unique, as you just heard another such story today. And I think at his 2011 Arbel conference party, somebody else also mentioned something similar. I think he recruited for the department, not just students that he would advise. Anyway, so those are the two positive things I remember more, but that'll do. And now, shortly after that, so it was my senior year. So I related the first one that came later, but the second one was in my senior year. And shortly after that, my father was wondering what getting a PhD in math was good for. He was a non-mathematical economist. So through a contact of his, he made an appointment with Richard Courant and took me with him to see him about this. So it turned out Courant was rather suspicious of a lot of trends in mathematics. And he, in fact, said that a lot of it is not generalization, but vaporization. And this is long before the word vaporware was coined in a neighboring area. But he had a high opinion of Tate. The gist of it might be, you might put it this way, if you are misguided enough to do pure mathematics, you couldn't find a better guide than Tate. That didn't matter to me at all, but I think my father felt reassured that going to graduate school in math wasn't necessarily jumping off a cliff as far as a career was concerned, or at least there would be a safety net. So now backing up, actually the time I first saw Tate was when I, in sophomore year, I took, I think it was called Math 101, it's a baby number theory course. I enjoyed the course, but the only concrete thing I remember was Tate drawing a droopy face on the blackboard, apparently, and I associated it with some defeat of Adlai Stevenson's. And I think he probably gave up on the Democratic nomination. This was 1960. And so that was an emoji long before the name was there. And the mathematical connection with Tate, I mean, I did all right in that course and so on, but I didn't get to know him. But the following year, so this was purely accidental. Two freshmen, no, not freshmen, sorry, at that time we were juniors, but two classmates of mine, one of whom was really the most advanced mathematically of my classmates. He had grown up at a university town and taken courses as a high school student, college courses. Anyhow, he arranged a reading course with Tate for the three of us. And it so happened that after a couple of meetings, the other two dropped out. And so I had this reading course alone with Tate, not my own doing, but actually years later, the last time I saw Tate at the 2011 Harvard conference at the coffee machine, among the small talk, he brought up that reading course and he said, "I'm glad you didn't drop out." And one of the dropouts later became a very famous lawyer, and many of you may have seen him on TV, but I won't mention his name. And Tate said, was that, in fact, when Tate brought it up, he said, "That big lawyer, was he a roommate of yours?" I mean, that's the way he introduced the subject. But anyway, he also, well, in that small talk, he asked me if I still played ping pong, which I had never played with Tate, but I had played with Sarah at Woods Hole. And somehow Tate knew that I played ping pong. And I never got to play basketball with Tate, which I gather was his favorite sport, because I didn't play the game even badly. But anyway, as a follow-up to that reading course, that summer, Tate said he had money left over from some grant, and he offered me a summer job, which would be to look at art in Tate and class field theory. So that nothing else was required. I mean, I would spend 1 or 2 months in Cambridge. Tate would be away. He, in fact, went off to Europe, I think. And but I had there were no requirements at all. So I settled on, I looked through it. The most accessible chapter, and therefore the most interesting to me at that time was, I think it's chapter 11 on ramification groups. And so I delved into that to some extent. The next follow-up, I don't remember the fall semester of senior year having had any contact with Tate, but I probably did. But in the spring, he proposed a senior thesis problem, which he said was one that he had himself worked on and proved. It had to do with generalizing the ramification filtration theorem on the ramification in local class field theory. The units in the field correspond, the filtration on the units corresponds to the ramification filtration. So that there's a generalization that Tate had worked on and apparently proved, he thought, which involves the Way group, which is, you take a non-commutative finite p-adic field extension and then the maximal abelian thing of that and look at the Galois group of that. Well, that's, the Way group is closely associated with that. And so the ramification filtration on that is related, conjecturally, was to the filtration units, to the filtration on the units of a division ring as opposed to a commutative field. So I don't know if that original conjecture was Tate's or somebody else's. Could have been Orton, Emil Orton, or Way, for example. Way later actually was interested enough to mention this conjecture, then a theorem in the second edition of his basic number theory. At any rate, so Tate said that he had himself proved it, but then lost the proof, and when other people had asked him for it, he had not been able to recall it well. He didn't want to spend tremendous amounts of time recalling it, so he proposed it to me as a senior thesis problem. So I don't know when he first gave me this problem, but I do know that until the spring break of senior year, I had got nowhere on it. I don't remember thinking about it even. But it turned out that, I went away on spring break to my parents' temporary apartment where there was not much to distract. I don't even know if there was a TV there. Anyway, by the end of it, I'd proved something and written it up, and then later submitted it to Tate. And in the end, it turned out it was all right, but he said that for quite a while he thought it was wrong because I had used some hybrid description of a group which on the face of it wasn't a group at all. That is, the general description didn't tell you that the thing was a group. And so I had used that. Now he's found out, he convinced himself eventually that that was in fact correct. And then he, so I'm going over time. Later on, so he wrote it up, he published it, we published it as a joint paper in the Indian Journal of Mathematics. The published paper has amazing hand-drawn diagrams with irregular quadrilaterals instead of rectangles and very wiggly arrows, okay? These amused Tate considerably, and but on page 1 there was an intentional joke by Tate. The footnote said the result, he had generalized, I'd proved it in characteristic 0, and he had generalized it to characteristic P, and he had combined that in this joint paper. He told me, I'm adding my 2 cents, while the result was probably 80% his. But at any rate, the footnote said the result in the characteristic 0 case was contained in the senior thesis of one of the authors. Okay, all right, I won't talk about my PhD thesis because others have to talk.
Thank you very much. I think I'm next. Yeah, I'm next. So I only have about 40 minutes of material prepared. No, so I arrived at Harvard in 1977, and wasn't sure whether I was going to work in algebraic geometry or number theory, but ended up drifting toward number theory. And I waited a long time. I didn't ask Tate to be my advisor till I guess my 3rd year, and started working on some stuff with pairings that didn't really lead very far. And Sarah gave a course on Diophantine geometry that later became this very nice book that he wrote. And he mentioned a question Tate had asked him of whether the canonical height had a uniform lower bound for all non-torsion points and elliptic curves over Q. And then it was pointed out that Lang had actually made a somewhat stronger conjecture about a lower bound that grows with the discriminant. So I started working on that, and had made a little bit of progress by the end of my third year, and then John disappeared and spent the year in Paris, which is the sabbatical that Greg Call was mentioning. And actually, we didn't have that much correspondence. I sent him a few letters. He sent me one letter and one preprint. So actually, this gives me an opportunity to do something that I don't think I ever did, but thank you, Barry, for being my advisor basically that year. I came in to talk to you plenty of times. It was great. And I got interested in elliptic curves through the elliptic curve seminar that some of the upper level students had started, and that was a wonderful thing. I try to tell our students, undergraduates, when they're heading to grad school, the faculty are great and courses are great, but one of your main resources is going to be the other graduate students. And the people at Harvard then were just wonderful. So Tate came back, and I started my 5th year, and I started writing up my thesis. And I handed him the first 2 chapters. Well, the first chapter, it just has all the notation and introduction stuff. The second chapter had a partial result on this conjecture of Lang's. And I went in a couple weeks later, and Tate said he'd looked at it, and I wish I'd written down the exact words, but it was along the lines of, yeah, that was very nice. I hadn't realized that would be so easy. Which I think, in retrospect, meant he liked the fact that it could be done with relatively elementary methods once you understood the underlying theory. Anyway, I defended my thesis in December, and then I really didn't get to know John until that spring after I'd finished defending, and we started working together on a project, which never actually led to a paper, but I learned so much about how one attacks problems by just sitting in the office, and he'd say something, I'd say something, I'd scribble on the board, he'd scribble on the board. So that was great. So I just want to tell 2 short, amusing things, one about that. Actually, both of them did, I think, really illustrate John's true humility, because when I say these, you're probably going to laugh, but he really meant them. One of them was at a seminar, a number theory seminar, I guess, and he was giving the seminar, it was, let K be a number field, let E be an elliptic curve over K, let T sub L of E be the usual module. The other one was while we were working together my 5th year of grad school, and he had made a suggestion, and I'd scribbled something on the board, and he really taught me the importance. You don't start by proving general fancy theorems. You start with examples and figure out what's going on, and then they become theorems. And I kind of stepped back, and I was looking at it, and John was looking at it, and then he kind of said, more or less to himself, I think, but it was along the lines of, gee, I wish I knew some algebraic geometry. And my thought was, wow, I bet you've forgotten more algebraic geometry in the past 2 months than I will learn my entire career, which is probably true. So I graduated, and John was an inspiration and a help for years and years. Wonderful interactions with him. And I'll want to finish with something not from when I was in graduate school, but much, much later when he had retired and was in Lexington, and he knew I was a pretty dedicated duplicate bridge player, and he'd started playing duplicate at the place where they lived, and his regular partner was out of town, so he invited me to come play, which I was honored, though I was a little rusty. And I made some mistakes, and he made some mistakes, and we ended up finishing last. And he was incredibly gracious about it, but it was clear, he's a competitive person, had always been a competitive person. He did not like losing. Thank you. Okay, next, Jeremy.
So hi, everybody. I'm Jeremy Teitelbaum. I was at Harvard from 81 to 86. I learned something, actually, about the mathematical community today because I came to Harvard from Carleton College, which is a small liberal arts college in Minnesota. And it's pretty clear to me now in retrospect that so for example, some of the words which I had never heard before when I arrived at Harvard were birch and Swinnerton Dyer and curve over finite field. And the whole thing was pretty overwhelming. And the reason I knew anything about math, and probably the reason I even had a chance at getting into Harvard, was because I had a very good mentor at Carleton College named Steve Galovich. And Steve Galovich was Mike Rosen's student. And Steve Galovich gave me some advice. And he said, go to Harvard and work with Tate. So Ken and I evidently got the same advice from the same source, just one step removed. To give you a sense of how overwhelmed I felt, I had a dream my first year as a graduate student. I used to go on bike trips, where you would go camping, and I had a dream that I was on a bike trip with a group of other people, and we had stopped like by the side of the road and unpacked stuff from our panniers, like you would, to have lunch or stuff. And that everyone else was then loading up their panniers, one after another, and riding off. And I just seemed to have so much stuff to put in my panniers, including a sofa, that there was just no way I was ever going to be able to get on my bike and catch up with these people. So I had this dream, and being very naive, had no clue what it could possibly mean, and explained it to my wife, and she has been laughing about it ever since. People have talked about what it was like. To me, Barry and John were, at least initially, kind of distant figures, and it was really the other students and the postdocs who really made life there so exciting, and that included Greg and Dinesh, and Bill McCallum, and Noam was there at the time, and we used to sit, it seems to me, for hours in the common room talking about math. There are a couple of people who are not here, and I think probably would have been if they could. That's Nigel Boston, who passed away recently, and the person who I really miss, which is Robert Coleman, who was a postdoc when I was there, and in many ways had really a huge impact on my development as a mathematician, because I talked to Tate, when the opportunity presented itself, but I talked to Robert a lot. So wherever you are, Robert, I know a lot of us miss you here. So I did have the opportunity, Henri called it the heroic age of computing, but I would just like to say that we were working in C, we had Emacs. This was not that heroic, really. But I was drafted by Barry and John because they had heard that I could program, which is evidence that you just have to be in the right place at the right time in order to get lucky sometimes. And I remember that I was given this job of computing this L function, which I dutifully did, and I got 0. And you may have heard of the Birch and Swinnerton Dyer conjecture, which said that it was not, very definitely not, supposed to be 0. And yes, it's a great story now, but the fact is they just assumed that I had made a mistake. And I distinctly remember sitting in John's office with a pile of printouts from the line printer of all the modular symbols, pages and pages of them. We were somehow going to find the mistake. And we're going through these numbers, and finally Barry says, I don't remember the exact words, but he more or less slapped his head because he had realized that the numbers went something like this: 5, 3, 2, -2, -3, -5. 5, 3, 2, -2, -3, -5. So it was pretty clear they added up to 0, and then he quickly realized that the innocuous term in the front of the interpolation formula vanished under certain conditions. And of course, for me, this was like being a part of that was incredibly exciting and a real piece of good fortune. And they were so generous in sharing credit with me that in many ways it made my career. And I've always been very grateful for that. That wasn't quite the end of my thesis. I did work on trying to generalize some classical formulas to compute kind of like generalization of the Tate curve. And I remember that I got myself into a huge mess. Everything was a mess. And I had one 2-hour meeting with Tate about this. And I basically came in there, and I had these equations, and I was using the computer, so I had all these printouts, and everything was a mess. And Tate said, okay, let me think about this, and he called me back in maybe a couple days later, and he had fixed all of my coordinates. And it took him basically a half an hour to explain to me how I should set up the coordinates, after which everything just flowed like water. And it was just a really, kind of an amazing thing to see. This wasn't deep, fancy mathematics, but it was like looking at a bunch of incredibly messy formulas and saying, let's just call this one P1, and this one P2, and this one P3, and then all your problems will be solved, and they were. So I feel extremely fortunate to have had the opportunity to know John, to know Barry, and to work with them, and to be a part of this great community. So thank you for having me.
Hello? Yeah. So I was here in 82 to 87, and John, of course, as everybody said, was very generous, kind, and very modest. I have written a memorial article on him called "Remembering John Tate." So I will not say much about that. I will say something about Arizona Winter School and John's relation with it. So when we talked, some of you talked about the golden age in 60s and so on. So I will just say something that I enjoyed tremendously learning about mathematics and number theory in particular with great teachers like John Tate and Barry Mazur. And we had regular visitors those time, John Pierre Serre and Serge Lang, who would visit for a term every couple of years. And then we had fantastic postdocs like Robert Coleman, Greg Anderson, Ehud Deshalit, Wayne Raskin, and fantastic students like Jeremy, Greg, then Norm, and Nigel Boston, Ching-Li Chai, Carlos Simpson. So I had a great time studying mathematics here. And then after a few years, I was in Arizona. We had a great group of colleagues. Again, Bill McCollum, Doug Ulmer, Min Young Kim. Then Wayne was in Southwest, and Philippe and Alex Boone. So that was our group. So we had a great time, but we were missing the intense graduate experience, which we had here. So that's how we started the Southwestern Center of and Arizona Winter School, and it's still running, still going strong, as Barry was there last week. And I should say that it was because of John Tate and Barry Mazur's participation and encouragement and their support. Because of that, it sort of, the experiment worked well, and it was going well. And in 25 years ago, in 2000, John's birthday comes on 13th March, and sometimes it falls on the Arizona Winter School Day, so this was one of those occasions. So 75th birthday was celebrated for the first time in the Arizona Winter School, and Jonathan Lubin and Nick Katz were there. And you can see some of these pictures in the Arizona Winter School webpage. There are pictures from 2000, so there is a celebration picture. Tate has holding some shirt, and there are some pictures. And there are pictures from 2007, which was the periodic geometry school, where you can see that he was participating in the late night student session. So there are several photos of him. And I can see the two speakers from here, Jared Weinstein and Wei Ho, they were students there. So you can see those photos. So he supported it wholeheartedly, and that's how it worked out very well. We came out with the proceedings of 2007 P-adic Geometry School, where I was very glad to get his preface, which says about how things originated at that time. So what did I want to say? Yeah, I wanted to end with the funny story about the winter school, where actually John and Barry were somehow responsible for it. So the school was, of course, meant for graduate students, right? But with Barry and John in front row, the speakers would always speed up. So what we did was we planted Min Young Kim to ask questions and slow them down. But it didn't work, because Min Young said, okay, can you please explain such and such? And the speaker looked at him sternly and admonished him, saying, Min Young, you should know this, and just continued. So I told this to John, and he was, as usual, very apologetic, and he said, oh, sorry, I don't have good vision, but I will fix it. So, and then basically he talked with the speaker and everything went well. So that's my story.
Thank you. Jim?
So I talked about my time with Tate a lot in my lecture, but I left out the bumps in the road. So let me tell you about one happening. So my thesis was to prove the Art and Tate conjecture, at least for some surfaces. So I was working on this, and one time I ran into Tate in 2 Divinity Avenue, asked me how things were going, and I said, I'd worked out one side of the equation, I got p to the 13. And I worked out the other side of the equation, I got p to the 17. 13 is not equal to 17, and so the conjecture is false. So when I told this to Tate, for a moment he was taken aback. Then he broke into a large smile, and he said, that's great. That's really great. Mike and I must have overlooked some small factor which you have discovered. And so he took me off to his office. And when I was working it out on the explaining it to him on the blackboard, of course, I found a mistake, and my calculation showed, in fact, that the Art and Tate conjecture was correct, and in the case I was looking at. So I apologized for being careless, and he said to me, well, everybody makes mistakes. Your error was not realizing that you had made a mistake. This stuff is too beautiful to be false. I think I'll just leave it there.
Okay, I want to thank everyone who's come up with all these wonderful stories, some of which I knew, but many of which I did not. And now, assuming I can figure out which button to press, which I'm not very good at. Yeah, here it is. Boop. And actually, I don't know how to make, can I make it full screen? assume the audio will work.
Hi, I'm Dick Gross. I wish I could be with you at this wonderful conference celebrating John's legacy. But in lieu of that, I just would like to record something about the experience of working with John as a graduate student. So John was a fantastic thesis advisor. He had in his career over 40 graduate students, and according to math genealogy, almost 900 descendants, many of whom are speaking at this conference. And I began to think about what were the qualities, what was his style that made him so successful as an advisor. And I think there were a few things. One, and this was really important, was that he took his students seriously. It took a while to get to work with him, but once you started working with him, he treated you as if you were a colleague. Lazy colleague, perhaps, or a colleague who had surprising areas of ignorance, but a colleague nevertheless. His door, when he was in, was always open. You didn't have to make an appointment to see John. You just came into his office. If you had some minor thing that had advanced, or maybe some contradiction you had found yourself in, and he would sit at his chair, at his desk, you'd be at the blackboard, you'd describe it to him as best you could, and sometimes he'd be able to just give you the answer off top of his head, or else he'd pull out of his files some letter he had written to Sarah on the subject that was better than anything in the published literature, and that would be a great thing. But more often than not, it would just end with John saying he thought it was a good question, but unfortunately he didn't know the answer, and you should just keep working hard on it. And you'd go away, and then about a week later, the magic would happen. And the way it would go is you'd be walking in the department, and you'd just pass by John, and he'd look at you in this puzzled way. I think there were two questions he was trying to answer. One was, were you one of his students? And if so, two was, what was your name? But once he had gotten that straight, he would say something like, Dick, you know, I've been thinking about what you told me a week ago, and I think I'm beginning to understand it a bit. Maybe I could show that to you. And you'd go into his office. John would take to the blackboard, and he would turn this crude piece of coal that you had brought him a week ago into a finely polished diamond. And it was incredible. I mean, you just would stand there and watch, and it was often not the answer to the question, but it might be a reformulation of it or putting it in context. But it was always amazing, and at the end, John would turn to you and say, so, is this what you were explaining to me? I may not have understood it in his way that indicated that you had done this, it's just that he was slow in getting it. And you would mumble something, but what you were thinking was, this is the way mathematics should be done. And that happened with all his students and time again. But those were like the small bumps in writing a thesis. And the second thing in John's style that I really thought was terrific was he gave his students a lot of room. You never felt like he was going to jump on top of the problem and solve it in 10 minutes, which he probably could have. He let you think about it yourself and structure it yourself and write your thesis yourself. John didn't say, what's lemma 1, what's lemma 2? I've heard these stories of other advisors. They just seem ridiculous. He let you alone. You were supposed to put it together. And he didn't really worry about what was in it until the last minute. And I remember my last year at graduate school, I gave him 3 successive drafts of my He says, and he thanked me profusely, but I don't think he ever looked at them. And then one day in May, I think it was maybe in the afternoon or evening, I got a frantic phone call from John. It's like, Dick, I have to defend your thesis tomorrow, but I don't know what's in it. And that was the quaint time that at Harvard, your thesis advisor defended your thesis to the other members of the faculty. You didn't have anything to have to do with it. You had to write it, but his job was to defend it, and John wanted to do a good defense, and so I had to come over, and he invited me over to his house, this wonderful place on Arlington Street, and I should sit down with him and tell him, what was in it. And when we finished, Karen invited me to dinner. I had many wonderful dinners at their house, and the girls were teenagers then, or at least Popper and Valerie were Popper and Jenny were teenagers, and and anytime John and I would start to talk math at the dinner table, they would start rolling their eyes. I remember that. And I think, Popper, we got our revenge when you had just Dustin. Anyhow, once John sort of understood what was in your thesis, of course, he'd come back a week or two later and say that he had a different way of looking at it, and that was, of course, a much better way of looking at it, and when you wrote it up, you would incorporate that. I remember 2 years after I submitted my thesis, and John and I were both in Paris, he came up to me and said, I've been thinking more about your thesis, Dick, and I thought about it in the context of abelian varieties with complex multiplication. He showed me this fantastic result he had on the conjugation of abelian varieties with complex multiplication by any automorphism of C, not just the ones fixing the reflex field. I said, boy, this is fantastic. Well, it just is sort of a generalization of your thesis. It had nothing to do with my thesis. By being open to us and listening to us on the small things and then giving us space on the large things so that we could go out in the world and work independently of John, that was a real talent and a really, really wonderful method of style. But I think what was really communicated to us as students was John's love of the subject of number theory and his great respect for the mathematicians who had worked in it in the past. It connected us to some of the greatest minds in the history of mathematics. And John was one of these giants, no question about it. A very modest man, a very unpretentious man, but a giant nevertheless. It's entirely appropriate that we honor his legacy at this conference. And for those of us who were lucky enough to have our first research experience under John's supervision, we were very fortunate indeed. Thank you.